Greeting everyone, and have you ever wondered how much you dream home might cost, or perhaps you are curious about the price of a property you are considering? Today we will explore how we can use a powerful statistical method known as multilinear regressions to predict house price by analyzing factors such as square footage, number of bedrooms, and location can estimate the likely selling price of property. Moving to the next slide, let me introduce our team. We consist of two members, myself, Thang, and the other Pham. And for the next slide, I want to talk about the project overview. So with the first, we will start by explaining why we're choosing this project. The next one is to explore the real-world application for house price prediction. The third one is to outline the technology we use to build this project. And the fourth one, that we walk through the software operational process. The last one is a future potential improvement. Moving to next slide, we explain the answer why we choose this project. So for the first part, the real world impact, the accurate house price prediction have buyer, seller, and investor make the more informed decision. The second one, the educational values. By working on this project, give the hands-on experience with the data science pipeline from data collection to the model evaluation. The third one, the practical application. So our model can be integrated into the website for API for the real-time estimates. And the fourth one, the last one, the technical challenges and the skill development. Besides these project challenges to refine the data science skill like data cleaning, feature engineering, and model evaluation. Moving to the next slide. So this is some real-life application about our model. As you can see, is a lot of the research paper that tell that use the house vibration to make sure that they use them to build a model to predict for each area like California, as you can see. Moving to the next slide, please.
So the tech stack here, first of all, the model training, will use the linear regression model from scikit-learn, and then we will explore the data, visualize the data to understand the relationship between the elements and the dependent variable. Library and tools for data processing and analysis, will use pandas and numpy from Python. Machine learning, we will use scikit-learn. Data visualization, we will use like matplotlib library, seaborn. Deployment, we will use streamlit, a Jupyter notebook, and for graphic user interface, streamlit and joblib will accompany us. So first, to understand about linear regression, we must understand the purpose of this is to find out a line that is balanced between all the residual here, so that the median the medium distance of the residual is as minimum as possible. So as you can see here, we have independent variables which will affect the dependent variables. We have multiple data points here, and our mission is to find a line that is somehow make the distance from the data points to the line itself as close as possible. So next will be the operational process. Here we have the workflow, data acquisition and cleaning, exploratory data analysis, model selection and training, model evaluation, and model deployment. For data exploration and pre-processing, first we will from the imported data, we have seen that the data frame itself has 2,919 rows with 30 different columns. And from the print out the types here, we see that it contains three data types here: integer, float, and categorical variables, which is called object here. And also with the data frame info, we can see that the sale price here is missing about 1459 values, which we will have to consider. So in the next step, we have dropped the ID column since it won't be contributing to the sale price at all here. Secondly, for the missing value, I have like replaced the null value with the mean of the sale prices here. As you can see here, we see mean here to like not disturb the distribution of the sale price of this data set itself. And thirdly, we will drop all the null value and check if there are any null value left in the new data set that I modified. So next, we will dig deeper into the categorical variables. As you can see here, we have 4 different columns, and in which they, in 3 of them, they have like maybe 5. They have like 5 unique variables, but in exterior ones, exterior first, we have like about 15 different variables here. So what to do about this? We will use a technique called one hot code encoder, so that we will make so that we can deploy each unique values of this column into a separate columns of themselves here. As you can see, first in the original data frame, we only have like 4 categorical columns, but here we have like more of them since we popped them out of the columns itself here. And if they represent a value inside a value, then the value of them will be 1, and the rest will be 0, to close to the binary, so that the model can understand and evaluate itself. So next, we will see the correlation between the numerical variables to the sale price. Here we can see I have created a heat map, and as you can see, with the value closer to the sale price here, closer to 1, it means that that variable have a stronger connection to the sale price itself. It means that it will have a important impact to the sale price itself. Here, total basement square foot, something like that. Year remodeled and year built. Yeah, as you can see here. After that, we will do something called train and predict the model, which I have imported the Trin's test split. It will split the data set, the original data set into 2 smaller or sub data set. One is for training purposes, which will take 80%, and the other is to test the test data set, which occupy 20% of the original data set. Here we have we have the X data frame here as the all of the columns, which are called the independent variables here, which will affect the sale prices here. Y here is the dependent variables, and our job is to, from the model, we will train from the model, and with the trained data set, X train and Y train, we will train a model that can predict the X test which will predict the Y value from the X test, and then from those prediction we can compare it to the Y test to see like how much of the differentiate from the actual value itself. Here, as you can see, the median we can see that the mean absolute percentage error here is 19.21%, and the median absolute percentage error is 14.47%, which is acceptable. Here we can see the graphic user interface workflow. First, we have to like input all of the number which we desire of the house features, and for all of the drop box with multiple options, we have here information box to tell you which value that it represent here in the size, standard, block width within the block, something like that. So here, after you finish all inputting the data, you will hit the predict button, and then the predict price here will pop out, showing our prediction from the model itself of the house price based on the feature that you provided. Here we have a video showing you how it is deployed. So that, yeah, after filling all of those variables in, and then we hit predict, and then poof, the outcome will appear. Here we can see that the mean absolute percentage error here 18.21%, so as a median absolute variable here, and the precision we calculated to outcome at 85.53%, which is acceptable. And the last part will be a future improvement, which will be presented by Thang.
Okay, so after we consider our project, we find out that we need some lot more improvement in the future. With the first part, the geospatial analysis, we utilize the geographic data to analyze location, specific factor, and spatial dependencies. With the second, we need to improve with the advanced machine learning technique by employ deep learning and several methods for improved accuracies. And the last part is we need to continuous learning by continuously update the model with the new data to adapt and maintain the quality of the model. And moving to the next slide. And
That's
that's all we want to talk about. Thank you for listening.